Cal 2, we were building polynomials in 9-7, so then I kept trying to make the connection that those polynomials with those variables x in there might be an infinite series. So anyway, we jumped to 9-8, and we call these things power series, and they are series with a variable x in them. And the question is, do they converge or diverge again? And for all these problems, we have these powers of x, so we do a ratio test. And really, the funny thing is, the question isn't, do they converge now, because the answer is always going to be converge. But the question is, for what x values do they converge? So, and the answer is going to be this. They either converge for all x's, negative infinity to infinity, and we call that the interval of convergence for all x's on the x number line, or they converge just for an interval like 0 to 2, or they converge, or they don't converge. You think they diverge, but what always happens, they always converge at the center point. And just for an example, we were talking about the center point when we built those polynomials, but you know, can you just stare at this and tell me the center point? Well, if it's x to the n, the center point is 0. This is centered at 0. If it's x minus 1 to the n, this is centered at 1. And so at the center point, if x was a 0, I would basically have 0 plus 0 plus 0 plus 0, and that converges to 0. So it's the trivial case. So when you think these power series diverge, they don't, but they just don't. Their interval of convergence collapses to just the center point. They converge at only one point, the center point. If x was 1, you'd have 0 plus 0 plus 0, and it's a trivial case where it converges. So we want to see if we can find the interval of convergence for this series. So I said we do a ratio test. So here we go. Let's see. I don't know if I can get through both these problems. The ratio test is the limit as n goes to infinity. N is the variable of the series. But there's a variable in the series called x. But anyway, here we go. It's the nth plus 1 term. That's x to the n plus 1 over n plus 1 factorial, divided by the nth term. But instead of dividing by the nth term, I always like to flip that over and multiply by the reciprocal of the nth term. So that's going to be n factorial over x to the n. Oops, x to the n. That's me dividing by the nth term. All right, I'm doing a ratio test. Let's see what we get here. Take the limit as n goes to infinity. Oh yeah, some stuff cancels. You know, I got x to the n, I got x to the n plus 1. I can cancel those x's. It leaves me one x up here. There's one extra x in the numerator. And if you remember how to cancel factorials, you're left with an n plus 1 in the denominator. Now, the variable of this limit is n. You're letting n go to infinity. So you can sort of treat this x like a constant. I'm going to pull this x out. It's the absolute value of x that's coming out, though, in front of the limit. And I'm left with 1 over n plus 1. By the way, these numbers n are positive. They're headed toward infinity. So I lost my absolute value. It was redundant to have them. But on that variable x, I needed the absolute value. So anyway, as n goes to infinity, I think that's what was left, right? We canceled that. Yeah. This is a 0. And so I have the absolute value of x times 0. Now, if you remember the conclusion of, by the way, that's 0. If you remember the conclusion of the ratio test, it converges when it's less than 1. So the question now is, for what x values is this less than 1? For what x values is this less than 1? And the answer is all x values. So, because it's always 0, and it's always less than 1. So this converges for all x. And we mean that's from negative infinity to infinity. And that's its interval of convergence. I might try this other one in a separate video here, but so before I finish this one, hang on just a second. I wanted to say something. You know what? This is famous. As soon as we move up, I keep mentioning 910, section 910. As soon as we move to 910, we learn about these famous Taylor series, and I called him out the other day. He's e to the x. He is e to the x. And so we did this ratio test, and we proved that it converges for all x. And we don't know what it converges to until we learn that this is actually e to the x. And so, if x was a 2, this series would be 2 to the n over n factorial. And you studied this back in early parts of chapter 9. What you didn't know was, and you could prove using the ratio test, you could prove he converges, but we never knew what he converged to. But if x is a 2, and this famous power series is this famous e to the x, and x is 2, then what does he converge to? Yeah, he does. What if x is a 1/3? This is a weird series here. There it is. And you could prove it converges, and now you know what it converges to. Because this series is e to the x. This converges to e to the 1/3. All right, hope you like that. 9-8, power series. You're not supposed to know this yet. I'm adding that in there a little bit. You're just supposed to do a ratio test and find its interval of convergence. Thank you.